Understanding the quadratic equation is helpful for anyone throwing or launching objects, traveling, and even making telescopes. What is the quadratic equation? How do we use it? And why do we care? This is what the quadratic equation looks like, and here is a quadratic formula. We label the terms of a quadratic with A, B, and C. Then we plug these numbers into the quadratic formula to find the quadratic's roots. What's a root? A root is a place where a quadratic crosses the x-axis, or when a function equals 0. One way to think about roots is to imagine the function's graph as a plant, and where it touches the x-axis, or the ground, is where its roots begin. Now that we know the roots of a quadratic, why do we care? Quadratics model a wide range of natural events, like the path an object travels when it's thrown or launched. As an example, here's an equation that models a possible path of a football being thrown. Using the quadratic formula on this tells us where the ball will land. Notice there are two roots. One root tells us where the ball will land, while the other tells us it will travel backwards. When solving a real-world problem, it is important to understand what your answers mean. One root provided us with a reasonable answer, and the other provided us with an awkward, arm-flailing movement resulting in the ball behind the thrower. Clearly, we aren't modeling how to incorrectly throw, so our first root is the real answer. Now that we understand how to use the quadratic equation and what it is used for, you are prepared to roughly model nearly any flying object.